Hello everybody, and welcome to the Internet of Water Coalition's webinar series. For those of you who might be new to this space, this webinar series is a reoccurring program where we bring together experts and organizations from across the full water data ecosystem to highlight progress, share case studies, and demo tools and technologies that are making water data much more discoverable and usable, really bringing the vision of the Internet of Water to life. My name is Paula Basili, and I am with the Center for Geospatial Solutions, which convenes the IOW Coalition, and I will be your moderator for today. Now, before we get started, just a quick bit of housekeeping. Two things really to remember. One, please use the Q&A function below to submit your questions. We're going to leave time to address those towards the end, but our speakers are going to be keeping an eye on them. So if in the moment, when you hear something, it piques your interest and you're like, oh, don't feel like you have to remember that question, feel free to drop it down in that Q&A below, and we'll be sure to get to it at the end of the presentation. And second, also, don't worry if you miss something. Like all IOW Coalition webinars, today's session is going to be recorded and posted up on our YouTube channel. So it will be there ready for you to revisit and share it with your peers as well. Now, today, I am excited to be joined by Mike Mahoney and Elise Hinman from USGS, who will be walking us through the new water APIs. They're going to highlight some new features and also share guidance on when and how to migrate your workflow so you don't miss a beat. With that, let's dive in. Mike and Elise, over to you.
Yeah, thank you so much. Thanks for having us. Let me steal the screen from you to pull up our slides. All right, hopefully that's coming through now. Yeah, thank you all so much for having us today. My name is Mike Mahoney. I'm the product owner for Water Data APIs at the USGS, joined today by my colleague Elise, who is with our computational tools group, to talk about changes coming to USGS Water Data APIs. Now, here at the USGS, we have a suite of tools and services that provide publicly accessible water data for the nation, and that we've been using to share this data on the internet for decades now. Unfortunately, over that time frame, these tools have become outdated. And so as such, we're currently engaged in a long-haul mission to modernize our systems, expanding the accessibility and usability of our nation's water data. We are extremely excited by these modernization efforts, but we want to make sure that we are showing our gratitude for the systems that we are working to replace and the legacy that they have left behind. The work we're doing today wouldn't be possible without the decades of tools that have been sharing this data that we're working to modernize. We also want to make sure that we are expressing our gratitude for the USGS partners and cooperators who make our observational network possible, including anyone who's on this call today. Again, the work we're doing wouldn't be possible without your support, so thank you so much for your partnership. Now, you might be familiar with a lot of these tools and services in the format of Water Data for the Nation, or WDFN. Those are our tools that provide maps, graphs, tables of latest conditions that enable graphical and interactive exploration of USGS water data. Today, though, we're going to be focused primarily on the left half of this slide, more developer-facing tools. In specific, our water data APIs, which provide access for repeated automated bulk downloads of USGS water data in machine-readable formats, and our computational tools, software packages for R and for Python, which provide access to data from those water data APIs and tools for working with it after it's been downloaded. Specifically today, we're going to be talking about changes coming to the WaterServices family of APIs. These are the APIs that provide access to the continuous sensor measurements that we collect, as well as the daily values that aggregate data from those sensors, metadata about monitoring locations, and manual measurements of groundwater levels. These APIs have been providing access to USGS water data for 15 years now and power a number of tools in addition to enabling direct data access. Among those tools are a large number of first-party USGS data products, including the National Water Dashboard and our monitoring location pages, as well as a number of products from federal partners, including the National Weather Service's National Water Model and flood forecasts. We also know that there's a wide array of private organizations who use our data as part of their products, including in a number of commercial tools. We are extremely excited to see how many people are interested in our data, and we're seeing that interest grow over time. Last year, we served about 2.5 billion requests to water services from over 10.5 million distinct IP addresses. And in the last 5 years, those numbers have more or less doubled. We're seeing continued and strong increasing interest in the data that these APIs provide. Now, unfortunately, these APIs have become increasingly difficult for us to maintain as they depend on out-of-date software and run on out-of-date hardware. So as a result, it's become really difficult for us to maintain these APIs, and in particular, nearly impossible for us to expand upon them to provide additional data or additional interfaces to USGS water data. And so as a result, in 2024, we started a project to release new modernized alternatives for these APIs. Today, I want to talk about that modernization effort. We want to highlight what you can expect from the new APIs, when you're going to need to migrate to them if you're currently using water services, and hopefully highlight some features of the new system that you can look forward to in addition to needing to do this migration. We're also going to touch on changes coming to our computational tools as they also migrate over to use the new endpoints. Now, in particular, I'm going to be talking about 4 of the endpoints available on water services, namely the instantaneous values or IV service, the daily values or DV service, the groundwater levels or GW levels service, and our site service. The statistics service has been modernized separately to better support our website's use case, and as such isn't fully described by the information we're going to be talking about today. And the old QW data endpoint has already been modernized with the samples data replacement coming online in 2024. So if you've already done migrations to use samples data instead, you don't need to take any action as part of this work. And so with all that said, what can you expect from these new APIs? Well, first and foremost, the new APIs are going to be implementing what's called the OGC API Features Standard. This is a widely adopted standard that specifies an API interface and a response object format that has significant interoperability benefits to it. Because we're using this widely adopted standard, there's a lot of tooling out there that automatically works with these APIs and with the data that you download from them. Additionally, because the standard is widely adopted, it should hopefully look pretty similar to other data providers that you might already be working with, making it easier to incorporate data from these endpoints into your existing workflows. That said, adopting this standard does mean that we are using a new interface for our APIs, and that means changes to how you build your queries and to the responses that we're going to give you back. So to walk through those changes, we should talk about an example API call. This here is a query to our daily values or DV service on water services. It's looking for a single site of data for a single day, the most recent day of data, that P1D in the string, for a single parameter code. And it's requesting that data back in the JSON format. An equivalent call to our new APIs looks like this. Now, the first thing you'll notice is that this new query is longer. A general trend with the new APIs is that we're trying to move away from abbreviations and codes towards more plain language for our parameters and our definitions. The goal here is to try and make queries more explicit and more readable. We want it so that you can scan a query and understand exactly what data is being requested just based off of the URL. But otherwise, these queries are structured very similarly to one another. If we walk through the components, we can see that. So the first big change is that the modernized endpoints live at api.waterdata.usgs.gov, not on water services any longer. The specific endpoints we're talking about today then have this longer subpath at OGC API/v0/collections. When we're building our query then, the first thing that we specify is what type of data we're looking for, which endpoint we want to hit. We now call our DV endpoint daily as part of that effort to make these more immediately parsable. The big exception to that pattern is our next argument. Thanks to the standard we're using, rather than saying format equals JSON, we use a code F equals JSON instead. But the rest of our parameters do follow this general trend. So for instance, we no longer request sites, we request a monitoring location identifier. This is identical to that site number that we've used for water services, but adds on an agency code at the front. We have an amount of furnished data that sometimes uses the same site numbers as other sites in the USGS network, but is collected by a different agency. And so appending this agency code to the front allows us to uniquely identify the location we want data from. We then add on our temporal filter. Rather than saying period, we say time, but we specify this in the exact same way as we would for water services. And then we add our parameter code information using parameter code instead of parm_cd. The thing I'm trying to emphasize here is that these queries are very structurally similar to one another. And that's because we're not changing anything about the actual data that you're getting from these APIs. You're getting these same building blocks, the same concepts that you're used to, just a slightly different way that you specify which fields you're interested in using slightly different names. The bigger change then comes in the response that you get back from the server. And so this is the response that that query would give from the legacy DV service. Now, when we do user interviews, we get a lot of complaints about this response. People generally describe this JSON object that Water Services gives you back as being verbose or chatty or bloated. And a lot of folks tell us they find it really difficult to work with. In particular, because it's a really complex and densely nested JSON object, it can be difficult to extract the specific values that you're interested in from this large blob that you get back. The JSON responses from the new server are comparatively much smaller and much flatter than what you would get back from the legacy system. In my experience, this format is much, much easier to then convert into a table that I can work with in R, in Python, and use for my further analysis. Plus, because this is a GeoJSON object that gets returned from our server, a lot of spatial software out there will automatically be able to read and process this data. This is also a much smaller object, which means that it takes less time for you to actually download this than a similar legacy response. Now, it's a smaller object because it doesn't include as much text as the legacy response did. The light gray on this slide is all of the various fields that no longer get returned. I think a lot of these fields aren't going to be missed. We no longer tell you the name of the server that handled your request, for instance, but some of these fields are going to be more impactful. For instance, the daily values and instantaneous values endpoints no longer return the same amount of metadata about the monitoring location and the parameter code associated with your data. We're making this change because the vast majority of requests to our APIs come from people who are looking for the most recent observations at a set number of monitoring locations for a set number of parameter codes that they are constantly querying for. As a result, those requests already have all of the metadata about their monitoring location, about their parameter, and it hasn't changed since the most recent data download that they made. As such, a huge amount of the responses from these services immediately gets thrown away by the user, which means that our server spends more time sending out requests, spends more time sending out data on the open internet, and you spend longer downloading that increased amount of data. By removing those metadata fields from these endpoints, we're able to increase how many requests our system can handle and cut down how long your download takes. But the actual metadata itself isn't going anywhere. It's just moving to its own endpoints. So our data endpoints, daily values, continuous data field measurements, have keys that you can use to look up the relevant metadata in the other endpoints that we now publish. So for instance, our daily values response has a time series ID corresponding to the new time series metadata endpoint, a monitoring location ID corresponding to the monitoring locations endpoint, and a parameter code corresponding to the parameter codes endpoint. That means that you can go and request the metadata that you're interested in once from each of these endpoints, rather than having to download it every single time you make a request against the data endpoints. We describe it as being like a set of building blocks that you can use to construct the full set of data that you're interested in. Now, all of these new endpoints live at api.waterdata.usgs.gov. And at this point, I should mention, every link I'm showing in this presentation is currently live. I'm not showing anything that hasn't been released publicly. And so you can go to any link that I've got up here and explore these resources for yourself. So on api.waterdata, you'll see all of these endpoints I've got highlighted here, our latest continuous, our daily values, monitoring locations, and time series metadata endpoints, as well as a number of other endpoints under the USGS Water Data umbrella, such as our Water Quality Services API. This website is intended to be a big tent that provides a central catalog of all USGS Water Data APIs going forward. Additionally, on this website, you'll find a documentation section, which provides a centralized catalog of long-form documentation for all of the APIs that are hosted in this catalog. The APIs we're talking about today are then collected under that OGC API key there. If you click that link, you'll find a collection of tutorials and worked examples about these APIs. That includes information on how you can build queries against these APIs, as well as how you can make more complex queries and more efficient queries, as well as a migration guide that should help you move existing code from Water Services over to use our modernized alternatives. These tables lay out every field that's returned by the Water Services APIs and where you can find that data in the new services. We're continuing to expand this migration guide as new endpoints come online, with the goal of having this be a living document to help folks make that migration over to the modernized endpoints. The last resource that you'll find on api.waterdata is our signup page, where you can access an API key for these services. Our new APIs use rate limiting, which means that if you make more than a certain number of requests per hour, you're going to start getting 429 errors until the next hour when your limit resets. This limit is currently set to be about 100 requests per hour per IP address if you do not provide an API key. And particularly for folks who are working in an office, that IP address is generally shared with other people using these resources. So that can be a pretty low ceiling. If you instead provide an API key that you get from this form, you get access to 1,000 requests per hour for your API key alone. And so you get access to this much higher limit that you don't need to share. And so as a result, we highly recommend including an API key whenever you're making requests to these services so that you always get access to that higher limit. This form, by the way, sends you the API key automatically to the email that you provide. I just like mentioning that while we have a box at the bottom for how you're going to use the APIs, we're not going to grade your responses here. It's something that's useful for us to qualitatively describe how people are actually using these services, but it's not something that's going to impact your rate limit or how you actually get access to these services. Now, the specific endpoints that are replacing Water Services have this longer path to their own specific homepage. It's this OGC API / V0 subpath. We're going to talk more about the V0 in a little bit, but first, I want to point out some useful links that exist on this homepage. First, on the right, you'll see a box that says documentation. That box has a link back to that long form documentation page that I mentioned, as well as a link to our reference documentation. It's an open API based Swagger doc that has more at-a-glance developer oriented documentation. The other thing to notice is that in the middle of the page, we have a number of cards that lead to each of our available endpoints. If you click any of those cards, you'll make a small request to the APIs and see the results on a nicely rendered page that looks like this. By default, when you access these APIs from a web browser, you get this HTML format back to hopefully help you build queries interactively so that you can explore and get exactly the data that you're interested in. If you instead access them from anything other than a web browser, you're going to get a JSON response back instead. Now, this JSON response contains the exact same data as that HTML. In fact, we view this JSON as being the authoritative version of our responses. It always includes all of the information that any other response format might. If you want to get the JSON format specifically or any other, you can add f equals JSON to the end of your query like I've got on screen here. In addition to HTML and JSON, we also have a CSV response format that you can get by passing f equals CSV. Now, you might also have noticed a next link on this slide at the bottom right of the map, between the map and the table there. And that next link also exists in our JSON response here as a link with a relation type, that rel element of next. These APIs use pagination, which means that if your query returns more than a certain number of rows, it's going to split your response into multiple pages of data, which you're going to need to request separately to get the full data set. This next link is how you know there's another page of data that needs to be downloaded. If you have a next link in your response, there's another page. Once there's no more next links, you have no more pages to get. You've downloaded the entire response. The two things to note about this, first off, the page limit is, or the default limit is currently set to be 10 responses to make that HTML table render nicely. You can, however, set that limit up to 10,000 using the limit argument, and we highly recommend doing so. We basically recommend always setting it to 10,000 unless your network can't handle downloading that many rows at once. Secondly, we don't currently have a good way to provide next links when you're downloading data using that CSV format. We're working on a solution here, but for the moment, if you get the same number of rows back as your limit argument, it likely means that you haven't downloaded your full data set. And so now I want to talk about some of the exciting new features of these APIs. I'm going to start off with small ones that might only be exciting to me, and then end on one that I think is of broader interest. First off, I mentioned earlier that our API URL ends in v0, and that's because we consider the current version of these APIs to be our v0. We're still adding features and endpoints that we consider to be core to what we want our modernized system to look like. Now, that said, that doesn't mean that these aren't ready for you to use. We actually use these APIs on our own website. When you load up a monitoring location page or anything else on Water Data for the Nation, you're accessing data through these APIs. But we are continuing to add endpoints, continuing to add features as we go. Once we have that core set of features and endpoints available, our intent is to release a V1 of these APIs. We're going to run this V1 in parallel with V0 for at least 6 months before we decommission that older version. We might also take this opportunity to make some small changes, things like adding spaces to field names or adding time zones to timestamps that are currently missing them, things like that. It's going to be much smaller than the change from Water Services, but we'll save it until we also have this new URL. This versioning means that we're able to save those types of changes until we have a new URL for you to migrate over to, while giving you plenty of notice and plenty of time to migrate your applications. This is something that was just never possible with Water Services. And so, as such, we sometimes needed to make changes to Water Services without first having a viable replacement available for folks. So, I'm really excited that this is something that we're baking in from day one here. A second feature that I'm excited about is that these APIs are built to be flexible. That means that you can make very flexible queries, but also that you have a lot of flexibility in determining what data you want back in your response object. Here, for instance, I'm specifically requesting just the value and time fields from a daily values endpoint. This can be useful if I'm, for instance, querying for a single time series where I already have all of my monitoring location and parameter code metadata, and so I just need my most recent values. By doing this, I can seriously cut down the size of the response object that I get back, which means that I can download these responses faster in a way that might be meaningful for performance sensitive applications. So if I'm building out a web app or something like that, this might change how I'm able to access data from these modernized endpoints. And then last but not least, the one that I think is of broadest interest is that because we're using this OGC API features standard, you can also access data from these services directly in your GIS. We have tutorials online for accessing data from these APIs in QGIS. We're working on ones for ArcGIS. I know folks are doing it successfully now. I just haven't written the tutorial for it yet. But by connecting in your GIS to our APIs, you can access data from these services by writing very little code. Here you can see all the code that's required for me to get the most recent day of mean gauge height measurements across our entire network. And then when I hit OK and add this to my map, I get those visualized locally in my QGIS. Because this is in my local GIS, I can then say, save this out to a file and use it in other analyses or email it to someone. This has been our most requested feature for years now, and I'm so excited that it's finally possible. And so my last note before I hand things over to Elise is that I want to talk about the timeline for these services and when you're going to need to migrate. We currently have almost all of our core endpoints available. So we have a daily values endpoint that replaces the DV endpoint, time series metadata and monitoring locations, which together replace the site endpoint, a latest continuous endpoint that provides the most recent sensor observation for every time series in the network, and then a number of lookup services like parameter codes, statistics codes, HUC names, and other useful metadata that was previously available on help.waterdata. We've also just released our field measurement endpoint, which replaces the GW level service while also adding in field measurements of discharge and gauge height. The one that's still missing is that continuous endpoint that will replace IV, which we are currently entirely focused on working on, as well as what we view as being additional endpoints, things like peaks and ratings, which never had proper APIs on the legacy system. If you have a use case that can be met by any of these modernized endpoints, we highly recommend that you look into migrating your application over to use the new services earlier rather than later. While we do not intend to decommission Water Services this year, and when we do have a date in mind, we're going to have much clearer communications and a timeline available for folks. We do believe that due to changes in our hosting environment, we may start seeing performance on Water Services in the near future. And so as a result, if you have an application that can use these modernized endpoints, we recommend looking into them earlier rather than later. The obvious elephant in the room is that the vast majority of our traffic goes to that continuous data endpoint, what we've called IV, and IV is not yet available. If that describes your application, we highly recommend looking at the daily values endpoint. It's not the same data. We're not saying migrate to it, but it is structured the exact same way as the continuous values endpoint will be. And so looking at how you would migrate your application using that daily endpoint can inform what you're going to need to prepare for once continuous is available. The other note that I want to make here is that we do not intend to release V1 in this calendar year. I mentioned that we're going to give at least 6 months of notice before you need to update URLs there, but we're not going to be asking you to immediately migrate again if you do start using those modernized endpoints now. We've got plenty of time before that V1 will be released, and the changes between V0 and V1, again, will be dramatically smaller than the changes from water services to these new ones. Things like adding a space to a field name, things like that. And so with all that said, I'm going to hand things over to Elise to talk about some of the changes coming to computational tools.
Thanks, Mike. So as part of the computational tools team, I'm now going to walk through how these API changes will affect the set of R and Python packages that we maintain. Next slide. So let's start with the data retrieval packages, which are helpful for pulling water quantity and water quality data into a programming environment. We've created analogous packages in R, Python, and even Julia. On the back end, these packages are doing a lot of the work of building the web service calls for you and processing the response objects into tabular data sets for further analysis. Next slide. So here's a quick screenshot of what data retrieval in R returns when making a daily values call using the legacy function read_enlist_dv. Next. And here's what the same call looks like in Python using the getDV function. The point I want to make here is that both packages return very similar data frames with a date column, a site number column, and a separate column for each parameter code requested. So it's giving you a wide format. Next slide. With the new services coming online, the computational tools team is hard at work creating new functions to accommodate these changes. We have started developing these functions in the R version with data retrieval Python following suit. Here's some of the new functions that are available right now. So on the left-hand side of the table, we have the existing function that uses the legacy WaterServices API to pull water data. So for example, read_enlist_dv on the left is the function used to pull daily values from the legacy WaterServices API. On the right side of the table, we have their eventual replacements, with read_water_data_daily being used to pull data from the new APIs Mike described. Note that we're in a period of overlap where both old and new functions will be available for use side by side. Next slide. So let's pause for a moment on a comparison between read_enlist_dv and read_water_data_daily, which is currently available for you to use. Similar to Mike's slides earlier, we can see that not only will the function name change, but the input names and parameterization of those inputs will change as well. For example, read_enlist_dv expects a string of numbers to represent the site number's input, while read_water_data_daily will have has an input called monitoring location ID that takes the agency name and the string of numbers separated by a dash. This ensures that the user's call will return a unique monitoring location, since it's possible for multiple agencies to have the same site number. Now, the parameter code input looks almost identical with a slight change in the input name. But what I want to note here is that read_enlist_dv returns each P code as its own column, also called a wide format. Read_water_data_daily, on the other hand, returns a flat or a long format, where if you were to request multiple P codes worth of data, each value for each P code would show up in its own row defined by a date, site, and P code. If you want to try out these functions as they come online, I suggest following the develop branch of data retrieval on GitHub. And that's where kind of the new functions get their soft launch, and you can try them out and provide feedback. Next slide. All right. Thus far, I've focused on the data retrieval packages, which are used to pull data from water services, the water quality portal, USGS samples, and now the new water data APIs. But I also want to make mention of another set of packages we maintain, in particular, HiSwap in Python and HASP in R. Both of these packages work seamlessly with water data obtained using data retrieval and are used to place surface water and groundwater into a historical context. If you're not familiar with them, you should check them out. Next slide. So of particular interest, these packages, particularly the HiSwap, possess many of the same calculations and capabilities as the soon-to-be decommissioned WaterWatch web pages. HiSwap's documentation available on GitHub includes a set of example Jupyter notebooks that walk the user through recreating some of the visualizations seen in WaterWatch, like the statewide streamflow conditions maps. Currently, the example workflows for HiSwap and HASP refer to legacy water services like read NWSDB and the getDB functions. As we develop these new functions to work with the new APIs, these packages will also be maintained and adjusted to include examples leveraging these cutting-edge data acquisition functions. Next slide. Finally, we've just talked about a lot of changes, both with the new APIs coming on and what's happening in the computational tools realm. And we want to make the transition as easy as possible. I want to point you to the Water Data for the Nation blog, which has a wealth of information on this transition, including a post about converting data from long to wide format, if that's what you need to do. Additionally, Laura DeChico, who is the lead developer of data retrieval in R, has put a lot of effort into creating high-quality documentation for using data retrieval, from individual examples on how to use each function, to more extended workflows called vignettes that not only pull data, but analyze and visualize the results. So this continuity will be maintained for the new functions coming online, both in R and Python. And as resources allow, we would also like to provide trainings on making the switch with these computational tools. You can reach out to us at comptools@usgs.gov, which will be on the final slide, if you have interest. And I'll pass it back to Mike to close us out.
Yeah, thanks, Elise. So I've got two final notes as we wrap up our presentation. First off, as we mentioned at the top, we're working on modernizing all of the tools and services that we have for accessing USGS water data. If you're interested in the other tools that we're working on, you can find more information about many of these at the new Water Data for the Nation homepage at waterdata.usgs.gov. And then last but not least, I want to say that we recognize that the transition to the new services is going to be a big change for a lot of people. And we want to be here to help to the greatest extent possible. And so I've got a number of emails here that you can reach out to for assistance. Going in order, this top email, gs-w_waterdata_support@usgs.gov. That is the best email to reach out to if you need any assistance working with the new services. We have a team that watches that inbox who will be able to help you troubleshoot any problems that you're running into. And if you have feedback on anything, they forward those emails to me, and I am fully happy to get feedback through that platform. It's really useful to us to inform future development, to find out what folks are having trouble with. If you're interested in participating in user testing, which is where we reach out to schedule either interviews or asynchronous exercises where we ask how easy it is to complete a task with these APIs, how easy it is to find documentation, what works well, what doesn't, reach out to us at WDFN_usability testing at usgs.gov. We're always interested in getting folks from outside the USGS engaged in our user testing. It's extremely useful to us to watch people interact with these applications so that we can identify common pain points that we need to smooth over as we continue working on these systems. And then last but not least, as Elise mentioned, if you have questions about computational tools, comptools@usgs.gov is the best place to reach out to for that. And so with that, I want to say thank you all so much for having us today. Excited to talk more about these services.
Mike and Elise, thank you so much. Wow, a lot of rich updates, that's for sure. We're really excited that you joined us today to kind of walk through those, and we've already got some questions in the hopper. Reminder for all of the attendees: if you do have a question for Mike and Elise, do drop it into that Q&A down below. So Mike and Elise, let's start off with the continuous endpoint, which I know you mentioned earlier isn't available yet, but we do have someone who's interested to understand, okay, how can I set myself up to set up that API so that it's ready to go when the endpoint is released. I think you mentioned to use the daily one. Is that right? Just to
Yeah, and so the daily values endpoint is useful to get an understanding of what the continuous endpoint will look like. It's got the same fields, the same names, same data types, everything like that. And so if you look at daily values, that's probably the best place just to look at how things are going to have to be structured when continuous is available to move things over. Uh, and so right now, that's probably the best place to look if you're looking to prepare for when that service is released.
nice. And just to stay up to date on to know, as soon as it is released, we're ready to go. What's the best way to stay in touch and stay up to date on that?
Yeah, let me grab the link and then I'm gonna ask you all to send this on to the chat.
Yeah, of
Uh,
course.
but we have a newsletter. Oh, I just saw that I have the permissions to do that too. We have a newsletter available that gives updates on the broader water data for the nation projects that includes updates to our website, monitoring location pages, things like that. Signing up for that newsletter is probably the absolute best place to get sent information about this. We also have a blog, and I'm going to send along a specific blog post that we use to post updates and usually longer form discussions. That the newsletter will send you updates about blog posts often, but that's additionally a great resource to look at for more information on developments, both on the API project and on the broader USGS water data side of things.
Awesome. So a couple of great ways to stay connected and stay in touch. And a small clarifier too, how does that continuous differ from the latest continuous?
Yeah, so we're moving towards an approach for folks who are familiar with the legacy system. Uh, you might be familiar with how if you don't specify a time range on your request to IV to DV, you would just get back the most recent observation for each parameter measured at each site. Those are now being turned into their own services. So the behavior now for continuous is that if you don't have a time range, everything matches. And so the latest continuous service provides that most recent observation for each, what we think of as being a time series, which is each distinct set of measurements for a parameter at a specific location. And so there's a latest continuous service that exists now that provides that most recent measurement. And for a lot of folks, that's all that they're looking for is the most recent sensor measurement for each site that they're interested in. Uh, I will say, wasn't included on the roadmap slide, but we will additionally have similar services available for daily values and field measurements, providing the most recent measurement in that series. Then the continuous daily field measurements endpoint provide access to that full period of record.
Very cool. Thank you. And I know you shared some resources and references. What would be the best place to land to actually get those API endpoint links? Is there a centralized spot for those?
Yeah, so I'll put two in the chat here. So as we were discussing, we've got this website, api.waterdata.usgs.gov, and that's the big tent website. That's the home for all of our APIs that are serving observational data and operational data uh, through these services. The endpoints we're specifically talking about today then have this separate homepage for because these APIs all behave like each other, they all follow that OGC standard. They live at slash ODC API slash V0. And so I've sent both those links in the chat there.
Awesome. Thank you. And thanks to those who also just say thank you for a great presentation. There's just some appreciation both to you, Mike and Elise. So thanks, guys. We were able to see that too. So want to make sure to pass that on. Okay. Jaspreet Gill actually has a question too around Python packages. There's a question around presuming that existing Python packages that access NWIS web services will also need to be updated to pull the correct new web API endpoints. Is that right?
The short answer is yes. So the ones that are maintained close to home are the data retrieval packages. And so those are the ones where we are very actively working on that modernization effort ourselves, uh, especially for like the Python ecosystem. There's a long lot of packages that access data that use a lot of hard to Google keywords for letting us know that they use water services. A huge way to help us, if you're willing, is if you open an issue on that GitHub repo and say, hey, are you updating to use the modernized services at api.waterdata? Uh, Huge help for us because we're trying to get the word out to those developers that they also need to modernize. Uh, and so if you open the issue, you can get the answer directly from the developers on when to expect that.
Nice, thank you. And on that note around feedback too, are there any particular kind of use cases that you all are interested in to kind of hear more about? Like, we have a wide diversity of folks on the line, so I'm just curious if there's anything in particular in terms of like real world deployment scenarios that you all are kind of keen either personally or just to help inform kind of the improvements moving forward to better understand.
Yeah, I would say, I mean, first off, everyone, thank you all so much if you are providing feedback. It is extremely helpful. I will say that given just where we sit organizationally, I tend to talk to a lot of people at federal agencies developing enterprise applications. And so I tend to, the first thing I think about when I'm thinking about users does tend to be folks who are pulling, the most recent observations for 8,000 sites every 15 minutes and things like that, like these really big use cases. And so, especially if you are a researcher, we know that like a lot of our users are doing effectively once per paper, more or less, one big pull of data. That's something that's not as obvious in our logs, not as obvious in our users. These researchers don't tend to need to email me very much because they did it once and then they didn't do it again for 6 months. And so, especially users like that, hugely helpful if you get in touch with what's easy, what's not, because it's a significant part of the user base, but it's a lot less obvious than the person who is downloading terabytes and terabytes every day.
For sure. Awesome. And I know you mentioned you all have previously run this webinar with Quasi, who is, another kind of Internet of Water Coalition member. And so great example of kind of trying to get in front of more of that academic audience. So if any attendees in the room know a great way to spread the word, don't hesitate to reach out to Mike and Elise.
Please.
Another kind of question. So how many concurrent monitoring location IDs and parameter codes can be bundled into a single API request using that R read water data daily function? Is there a limit to rows return? Like what should folks expect there?
So Bob might, or not Bob, sorry, I'm looking at the Q&A and Bob's question's up next. So Elise might correct me on this. And I think this answer changed recently. The hope of data retrieval, and these endpoints are coming online as we speak, and so some of this is developing more actively. Uh, the goal with data retrieval is that you shouldn't need to think about, how many IDs you can send in a request and so on. Hopefully, data retrieval handles that under the hood for you. Now, the reason I'm saying it like this is because that might be something that I have talked with the developer about, and is intended and isn't the current version. Uh, Elise is telling me that's, yeah.
Yeah, as I understand it now, or last I pulled a lot of sites using the new services, it was around 250 before you wanted to chunk that up into chunks of sites and kind of iterating over them. But you're right, there is discussion of how can we keep the user from having to do that and do that under the hood. So,
Yeah.
but that's where it's at right now.
Yeah. Part of the issue answering this question is that the actual limit is the size of the request you're making. And so if you're requesting a lot of like stream sites, which usually have 8-digit numbers as their identifier, you can usually get away with 300 of those. If you're requesting a lot of groundwater, which have 13-digit identifiers, it's just literally more text. And so you run out faster, and 250 is a safer limit.
Awesome. Thank you for that. Now, a short, simple question. Is watermouth fully abandoned?
Yeah, this is the one I was staring at when I said Bob's name.
Yeah.
Um,
Thank you, Bob Lou.
so I've got two separate answers here. The first one is that we aren't intending to provide WaterML as a response format from the APIs. What we've heard from users is that the interoperability benefits that it promises just don't make it, or just don't justify the difficulty folks have interacting with it as a format. In particular, the XML version of it in the current era, there's just not a lot of things that can automatically read or write that format. And so folks found it really difficult to work with. Now, we are still using WaterML in our hearts, where if you look at the names that we use for the JSON responses, the field names that are those expanded versions I mentioned are taken primarily from the WaterML and time series ML standards, as well as that overhead OGC observations and measurement standard. So we are attempting to carry through what the standard was trying to do with the terminology that we're using so that hopefully we are still clearly communicating what each field represents to users. There are some exceptions due to just USGS historical naming conventions and things like that, where we had to use traditional names rather than the WaterML preferred identifier. But we've attempted to do that. And something that I'll mention that we don't have a formal plan for right now, I don't have a date that this is coming, but we've discussed conversion packages as a additional add-on where you would download the data in the USGS JSON format and then have a computational tool that could do the conversion to WaterML if you need that format for other purposes. So I don't want to say it's fully dead. I will say that it's not being returned from the server at the moment.
All right, thank you for that. Um, Elise, one, and just again, reminder, if you do have any questions, Q&A is the place to ask them. But Elise, one question for you actually, because just to bring things back to the Python packages that I know, you and the team are really working to update. I'm sorry if I missed this, but was there an update around kind of like the timing of that and when folks should expect it? And I guess similarly, what's the best way to know, when those are out?
Yeah, it's an active development right now, putting those functions online and kind of mirroring the structure of how those functions are designed in R to try and make them, I mean, they're Pythonic, but similar across those different packages and systems. So, hoping within the next month we'll have, a develop branch on Data Retrieval Python's GitHub where you can go and see the functions, coming online and try them out. And so the intent is, by fall to have them have the set that we can have available on the main branch and working well for users.
Awesome. Okay, so lots of activity happening in the fall. That's great. And then I think we have our last question, but this one is around kind of bulk download, right? So there's other APIs that have added that bulk download option, so the service isn't being too taxed, which we know can happen. Is that something that USGS has considered doing to avoid chunking out calls? I don't know. Any insight you can share there?
Yeah, so I'm going to put the disclaimer at the start and the end of this answer that this is not something that we are currently working on, and I do not have a timeline to share. So I can tell you what we're thinking about, but that's where it ends.
Sure. Yes.
Uh, and so our current thinking around bulk download is that if you look at our data structure, this is something that for folks who are tuned into like the open data and the cloud native geospatial stuff, it's something that seems like perhaps a natural fit for just say a czar data lake in S3 that we provide folks with direct access to with a perhaps or a stat catalog that you can use to find specific chunks of time for specific monitoring locations, things like that. And so we definitely think, there's solutions out there that are great fits to this problem, especially for folks who are interested in huge data pulls once every 6 months. Like that's a really natural way for us to enable that. It's something that we definitely want to support. Now, as we were talking about in the presentation, we're currently entirely focused on getting continuous out the door. We're focused on getting proper APIs up for peaks, ratings, those other unofficial services that we had. Uh, and so this isn't something that we just frankly have the time for at the moment, but it's definitely the next step that all of us are really interested in pursuing.
Awesome. So on the way, hopefully, fingers crossed, on the laundry list.
Yeah, no promises, definitely something that we are discussing.
Yeah, no need. Awesome. Well, okay, Mike and Elise, thank you again so much. I think that wraps us up for questions. Thank you so much for joining and sharing the latest, what you need to know about these great updates moving forward. Really appreciate you guys taking the time. And thank you also as well to everybody who attended and joined us this afternoon. Again, this IOW Coalition webinar series is really here to bring to life the great work that's being done across the entire water data ecosystem to help modernize our water data infrastructure. So if you all have any projects you're working on yourself, any tools or technologies that you're either excited to present, this platform is here for you. So do let us know. Don't hesitate to reach out with your ideas. Or if there are topics, themes, conversations similarly that you're would be interested to learn more about, let us know. We're happy to kind of get the right experts in the room to get you the information you need. So again, thank you again so much to everybody for joining us. As a reminder, we do have another webinar scheduled September 15th. This is an exciting one where we're going to be focusing on the GeoConnects Explorer, which if you have been with the IOW journey for a while, you may be just as excited about it as we are. We know it's a great kind of culmination point for bringing that like back end GeoConnects infrastructure to a little bit more of a front end. So excited. Our team will be walking through kind of what that looks like, how it can help, and where it's headed next. So with that, Mike and Elise, thank you again so much for joining us, and I hope everybody has a great rest of your day.
Thank you so much.
Thank
Bye.
you.
Everybody,
Bye.
bye.